Question 4. The curve with equation y equals f of x, where f of x is equal to x squared plus ln 2x squared minus 4x plus 5, has a single turning point at x is equal to alpha. Part A. Show that alpha is a solution of the equation 2x cubed minus 4x squared plus 7x minus 2 equals 0. Okay, now let's look at this. It says we have a single turning point on our curve with equation f of x. We know that with a turning point, the gradient at said point is 0, which means if we were to differentiate this f of x to find our gradient function, then we can put it equal to 0 at our turning point alpha. So if x is equal to alpha as a turning point, then f dash alpha will equal 0. So we have our f of x, x squared plus ln 2x squared minus 4x plus 5. So let's find f dash x by differentiating. Now when we differentiate x squared, of course we multiply by the power and then subtract 1 from the power, so this becomes 2x. When we differentiate natural log of x, we actually get 1 over x. So in this case that's 1 over 2x squared minus 4x plus 5. But given our chain rule, we need to multiply it by the derivative of this component. 2x squared differentiates to 4x, and minus 4x differentiates to minus 4. So this is our gradient function, 2x plus 4x minus 4 over 2x squared minus 4x plus 5. Let's put that equal to 0. Now the first thing I'm going to do in order to rearrange this is multiply everything by 2x squared minus 4x plus 5. So 2x times 2x squared is 4x cubed. 2x times negative 4x is negative 8x squared. 2x times 5 is 10x. And that's plus 4x minus 4, which is 0. Simplifying this gives me 4x cubed minus 8x squared plus 14x minus 4. This, of course, can all divide through by 2, which gives us 2x cubed minus 4x squared plus 7x minus 2 is equal to 0, which is what we wanted to show. Our iterative formula xn plus 1 is equal to 1/7 of 2 plus 4 lots of the previous term squared minus 2 lots of the previous term cubed, and is used to find an approximate value for alpha. Starting with x1 is equal to 0.3, calculate, giving each answer to 4 decimal places, the value of x2 and the value of x4. Now we're going to look at how best to do this on our calculator. So let's look at how to answer these iterative formula questions on our calculator. Now we're told that our first term is 0.3, so if we actually just put 0.3 in our calculator and hit equals, this is now the most recent answer on our calculator. So if we go ahead and type in our iterative formula, which is 1/7 of 2 plus 4 lots of whatever our previous term was, in this case it's our answer squared, minus 2 lots of whatever our answer was now cubed. So what I've done is I've typed in the iterative formula on my calculator. So when I hit equals, this finds me my second term. I could push SD here to see that I've got 0.3294, 2a and so on. Now if I push equals again, that gives me my x3. If I push equals again, this is my x4, which I can see to 4 decimal places is going to be 0.3398. And of course I could find more, should I wish. So you'll note I started with x1 being equal to 0.3, which becomes the initial answer on my calculator. We typed in the iterative formula carefully on our calculator. Hitting equals once gave us this 0.32942 and so on, which is 0.3294 to 4 decimal places. And as we saw, hitting the button twice more to get our fourth value, we got 0.3398 to 4 decimal places. Using a suitable interval and a suitable function that should be stated, show that alpha is 0.341 to 3 decimal places. We have already shown alpha to be a solution to this. That means alpha is a root of this equation. Now, given that alpha is a root, that means there is a change in sign in values both before and after alpha. So since we have alpha to be 0.341 to 3 decimal places, let's look at if a change of sign exists between the lower and upper bounds of this number to 4 decimal places. So 0.3405 would be the lower bound, which rounds to 0.341, and 0.3415 would be the upper bound. We're going to take this expression as our equation g of x, and let's substitute in our 0.3405 and 0.3415. Substituting in the lower bound, we get a negative answer of 0.0013 and so on. Substituting the upper bound, we get a positive answer of 0.0036 and so on. Therefore, given the change of sign on this continuous function, alpha must be 0.341 to 3 decimal places.